Hello everyone, welcome back to a new video. In this video, we are going to talk about Kubernetes volumes. So we will talk about what are volumes, why are they used, and then we'll talk about these different types of volumes, few of which I have mentioned here. We'll talk about what are these volumes and then why do we need these specific volumes, why do we need persistent volume, and other than that we will also look into a hands-on tutorial on how we can create all these different types of volumes so that we just not only study the theory but also practice it on our cluster. So let's get started. Let's start with what volumes are. So volumes are like folders that are present inside a pod and that can be accessed by the containers of that pod, and they would provide this persistent storage. Persistent means basically that does not die. So persistent storage, I mean that even if the container dies, the storage and the data inside that storage, which is a directory, still remains. So even if the container dies, the data remains in the pod. If the pod dies or the pod restarts, because restarting is what the pod dies and a new pod is created, so it's a new pod. So at that case, the volume will be gone. Now, why do we need these volumes? I think that is self-explanatory now. Firstly, like I said, persistence, right? Data persistence is important. So even if the container restarts, the data is still there. Then second is sharing data between containers. So it allows like multiple containers in that pod to share the data. Then you can look at these types of volumes. Before that, I think we should go to the official Kubernetes documentation. Let's search for volumes. And like here also it says, Kubernetes volumes provide a way for containers in a pod to access and share data via the file system. Like it says, it is a way because through which the containers in a pod can talk to like share data with one another. Like it also gives an example, config maps and secrets. So if you remember in our config maps and secrets video, I also said that config maps and secrets are mounted as volume, right? So if config maps and what do config maps and secrets do? They hold sensitive data or these credentials, data credentials, these API tokens and all. So that is what we are trying to do with config map and secrets as well. We are trying to create the storage or create this volume through which we can share the data, right? Share the data, these sensitive data or the credentials, etc., to the pod. That's why config maps and secrets are also mounted as volumes, and that is the best practice. But there are other ways to also work with these config maps and secrets, like directly injecting them to the pod. Like it says, why are volumes important? I have talked about this. Data persistence, so that even if the container restarts, the volume and the data is still there. Shared storage, different containers in a pod can share the storage, can use the storage. Then it talks about how the volume works. I wanted to show you this types of volumes. So there are a lot of types. You can see these are deprecated ones. So the AWS Elastic Block Store, Azure Disk and all, these are all deprecated. We will see some more here. This is config map, then downward API, emptyDir. We'll talk about emptyDir. Then there is fiber channel and a lot more. So these are all types of volumes. The most important ones we should talk about and which are really important and which we will use also in our tutorial will be these four. So first is this emptyDir. So what is emptyDir? EmptyDir is like temporary storage for the pod. So in this case, if pod is removed, then the data will also be removed. So it's very basic form of volumes. If pod goes away, then like the data also goes away. Then there is this host path. So host path basically mounts this file or a directory from the computer or like the pod or not pod, the node that you are using or the VM that you are using into the pod. So it's like, if I have to draw it, then it would be like if this is my node, or you can, it is basically a VM or whatever you call it, node or your personal computer or whatever, and we have a pod running in it. So what it does is, like in this node there would be multiple directories, right? So there would be one directory called /etc, and then there would be another directory called home, another one for example, let us say .cube, etc. A lot of directories, right? So we can have one such directory, which let us call it var/lib. You can call it anything, slash storage. So you can call it anything. And what we can do is we can mount this into the pod basically. So what happens is, for example, if this storage contains some files like a.txt, then if you go to the pod and if you check out this particular directory, then you will also see, what do you call it? What did I say? A.txt, right? So you'll also see a.txt at the pod level, right? If you enter anything in the pod, you will find it here as well. So what will happen? See, what happens is, even if this pod dies, okay, I I killed everything. I should have only killed the pod. How do I do that? Even if the pod dies, this still remains, right? So until this is gone, we still have our data. That's why this is independent of the pod's life cycle. So even if the pod would die, we would still have the storage, var/lib storage, and we will have the data. And if this pod dies, another one will be born or whatever you call it, restarted or created. So the pod 2 will still be looking at this directory. And if you then exec into the pod 2, then you will still find this directory and all the data inside it. So that's how host path works. Next one would be persistent volume claim, or it is also called PVC. So persistent volume claim is basically used to create this persistent volume, which is a Kubernetes object. So what it does is it would connect this pod to a persistent volume. We have an example here. So it would connect the pod. This is the persistent volume claim, and it would connect the pod to a persistent volume. Now, what is a persistent volume? See, you can see this is like a pool of persistent volumes. So the persistent volume that you see here is nothing but it is the storage in a particular cluster that basically exists independent of the pod, just like it happens here. But in this case, it is not like some directory and all. It can be some like cloud storage by AWS, GCP, etc., or it can be like on-premise storage or local storage, rather than just being a directory in this particular node. So how this works is, if you look at the pod, what happens is, firstly we will have a pod, right? What we will do is we will create a persistent volume, which is also a Kubernetes object, and we will also create a persistent volume claim. Now, before doing that, I think we should also talk about these access modes, because this is very important to understand how this works. So what are these access modes? I'll tell you what I'll tell you what they mean. Before that, I'll just talk about what these types are so that we can explain this diagram here. So the first one is read write once. So read write once, as the name suggests, basically means that it can only be it can only be read and it can only be written into by a single node. Can read/write. So read write once means that only one node can read and write to the volume. And even if like multiple pods are running, only the pods on that one node can use it. Other nodes can neither even read it or write into it. Then there is read write. Then there is read only many. So read only many basically means, like the name suggests, all of them can read and only read. So multiple nodes can read, no one can write. So with read only many, multiple nodes can read the volume at the same time, but no node can write into that particular persistent volume. And the final one would be read write many. So as the name suggests, multiple nodes can read and write at the same time. So the read write many, in which, so in the read write many, multiple nodes can read as well as write at the same time. So these are the types of access modes. Now you would know what access modes are. Basically, how nodes can access that particular or pods inside those nodes can access that particular persistent volume. So read once, read write once, single node can read or write at once. And then there is read only many. So multiple nodes can read but only read at a time. And then there is read write many. So multiple nodes can read as well as write at the same time. Now, why did I tell you access mode before? Because if we have a pod and we have a claim, okay? So for example, this persistent volume pool is of 100 GI. Now, out of that 100 GI, let us say this claim is asking for 10 GI. Now what happens is pod can use this claim to use or to claim this persistent volume, but with a condition that the claim should be asking for a storage or amount of storage which is less than the total persistent volume or equal to. Like in our example, if persistent volumes are of 100 GI and the claim is of 200 GI, it would not work. But if the PV is of 100 GI and claim is of 10 GI, then it can work after we check the access modes. So if the access mode of the persistent volume and the access mode of the claim match, and also if the persistent volume claim is asking for less than or equal to storage of persistent volume, then the pod can use claim to access this persistent volume. So that is basically how persistent volumes work. So a pod will claim a volume using this persistent volume claim. Simple as that. And then we already know about these config maps and secrets. These are just like configuration files or sensitive data like passwords and all, or API tokens, API keys, etc., that we can inject to the pod or that we can mount as a volume as well. So config maps would not include the sensitive data, and the secrets include sensitive data because that will be encrypted. So that is what these types of volumes are. And I think I discussed everything in theory part. I think yes, I don't have anything else. So we talked about the access modes, and then there is these reclaim policies. Maybe we can talk about reclaim policies later on because otherwise that would be confusing. For now, let's move to the tutorial now. So I am going to use Killer Coda for this tutorial. I'm using a CK environment, so it would simulate the CK environment which uses Kubernetes 1.31 as of now. So you can use your local cluster if you want to, or if you have a self-managed cluster on VMs or on AWS EC2, so you can also use them. So let's get started. First, let me go into the file system. Now what we are going to do is, let's go to volumes and we are going to create an emptyDir right now. Let me search for emptyDir and we would come back to the same documentation page. Maybe we'll get it in infernal volumes. Yes, we have it here. Actually, we are back at the same volumes documentation, which is fine. Let us use this one only. So now this is emptyDir configuration example. Let us pick up this YAML configuration for our reference. So we will go and we will create a emptyDir. Let's call it ed.yaml. And I will paste all the content here. Now we can change a few things here. So I'll call it pod with emptyDir. And then we can use some other image, like let us use a basic Nginx image. Then in the mount path, I think we have this HTML folder in Nginx. We should use that. So let's save it to user usr / share Nginx HTML. So we'll save it here because here we can keep our index.html file, and then name we can keep it anything. Volume. One important thing here is, see, volume mounts is what we have created this volume here, and then this volume is mounted into this path of the pod. So that's what we need to remember, that the name of the volume and the name inside the volume mounts should be same. And then the type is emptyDir. Size limit would be 500 MI, which is roughly about 500 MBs. If you want to know the difference between MI and MBs, then let me show you. So if you see, it is roughly the same. So if you ask for, like, let's go to megabyte. Megabyte and say 500 megabytes. So it is roughly around the same only. Let's go back. And I think this should be correct now. So we can apply this configuration. So with that, the pod has been created. Let's do k-get pods and give it some time for the container to be running. Container is now in running state. Now if we do kubectl describe pod, the name of pod was, I forgot, k-get pods. Call pod with emptyDir, and there are no issues with the pod. Yes, no issues. And now if we see the volumes, then we will see this cache volume or cache volume with the type emptyDir, and then the size limit, and where is the mount. So you can see this user / share / nginx / html. This is the mount path for the volume, and everything else is fine here. Yes. So that is what I wanted to show. That is how we can create these emptyDirs. Now let me try out one more thing. Let us try deleting the container and restarting the container and see if the data is affected because of that. Okay, we did not try out adding few things into the volume. Let us do that. So how we will be going to do that is, let us say k-get pods, and I'll copy the name of the pod and we will do exec into it. and let's use bash kubectl exec. Okay, so that was the command. Yes. Now what we will do is we will get inside user slash share slash nginx slash html. Now inside this, if we create a file and let us say 1234 and let us put it in a file called index.html. Now if we do ls, then we can see this index.html is present here. Now if we can restart the container, then it will still be there, but if we restart the pod, then it will be deleted. One thing I want to try out is I want to show you where it is present in the file system. So this one is also present in the file system technically, and for that we need to go inside the etc slash kubelet. Let me search for kubelet. There's nothing called kubelet. I don't think kubelet is present in etc. Let me look out for var slash lib. So let us go into var slash lib slash kubelet. So yes, it is present in var slash lib slash kubelet. Now we will do ls. Get inside the pod section and you will see all these pods. Now we need the pod ID of our current pod. For that we'll do k describe pod. Name of our pod was pod with emptyDir, and let's try to find the pod ID. Okay, we are in the control plane, and this is not in the control plane obviously. Why? Because in the control plane we have the state which prevents the workloads to be scheduled into the control plane. Forgot about that. Let me ssh into the node, which is I think node 1. Let us confirm that as well. Okay, get nodes. Yes, node 01, it is correct. And here we will do the same thing. Let us first go to the file system. Then inside that var slash lib slash kubelet slash pod, and then the UID. Now it should work. So it did work. And now in the volume section, you will see this emptyDir. Is it a file or is it? It is a directory. So let us go inside that. And here we can find this cache volume. And if you remember in our tab 1, let me do okay, get. Do we get volumes? No, but k get pods and k this. Okay, let me find that command. K describe pod. Let's remove this from here. And you will remember that we created this volume called cache volume, which was an emptyDir. So that is it where it is kept. So these empty directories or emptyDirs, these are actually similar to hostPath. You can see that. And these are actually stored here. Now if we go inside the cache volume, you will see the index.html here. And now let me do one more thing. Let me do echo. Let me say 4321. Let us put it into home.html. And now let us go back to our pod k exec into our pod, which was named pod with emptyDir. Let's use bash. So we will go inside the user slash share slash nginx slash html, and you will find this home.html here. So that is basically how it works. That is where the emptyDir actually resides. That is where the emptyDir volume actually resides. So that is basically how emptyDir works. Now let us do one more thing. Let us try to restart the container and see what happens. So we are inside the pod right now. Let us go back here, clear everything up. And what we will do is we will try to see the processes that are running right now. So pu, ps, aux, and the ps command is not present here. So first we will have to install it. Let's do that by apt-get update and apt-get install proc ps. So ps command is basically used to list down all the processes that are running in that particular pod. Now if we do ps, yes, we can find the processes, and if we do ps aux, you'll see all the processes that are running. So we have this nginx process that is running here. Now for making sure that the container restarts, what we will do is we will kill the root process itself. So for that, the command is kill and then the PID. So we'll use 1. So the command was terminated with this exit code, and I think the container would have been restarted by now. So if we go to the same directory again, which was user slash share. What's wrong? Okay, so we came out of the pod right now. So let's exec back to the pod. Let me find it through history. And in that, we will do user slash share slash nginx slash html. And you can see our home and index directory still being present here. Whereas if we have done this without using the emptyDir, let us do that as well. Let us go to a new tab, and what we will do, we will do k create pod. Let's call it nginx. Image would be nginx. Okay, so this is not create, this is run, and we do not have to specify pod. And the nginx pod is also running. We'll do exec into it. K exec it nginx. Let's use bash, and let's do it a little bit quickly. apt-get update and apt-get install proc ps -y, so that everything is answered as yes. It'll take some time, and we have the ps command running. Let's do ps aux. So here aux basically means a means all, and u means the show us in a user friendly way, and x, as far as I do not remember about x, but it is basically showing up all the processes that are running. You can search what the x means here, but for now what we will do is we will kill the process with PID 1. And okay, I made a mistake again. We did not enter anything into the into that particular directory. So let's do it again. Actually, what I could have done is I could have used this pod only, and in some other directory I could have saved other things. Now I am realizing this, but no issues. Let us go back. Let us go to the usr slash share nginx html. No problem. This will be even better because it will be easier to compare because we are going into the same directory. So let me echo 1234 into this particular file. Let's call it index.html. And we have this index.html here, and there is something called 50docs.html, 50x.html. I don't know why this is there, but anyways, we'll do ps aux. PS command is not there. Install it again. Apt get the update and apt get install proc ps dash y. Act get, no, apt get, sorry for the misspell. And we have it. Let us do ls again. We do have our index.html. Let's do kill one, and the command was terminated with exit code 137. Now let's do exec again. What? Let's do exec again. So I think it took some time to create the container. Now let's go back and see what's there in the user slash share slash nginx slash html. So we do have this HTML page, but it is different than what we created. Okay. It was not there earlier. Now what should we do? Let me do one thing again. Let me do echo into another file. Let's call it home.html. And now we have to do the same thing again. Apt-get update. Sorry for repeating it so many times. Apt-get install. Maybe you can also practice it so that you also can remember these commands. So that will be helpful. Apt-get update and apt-get install proc ps. Let's kill one. Exited. Let's go back again. It'll take some time for the container to restart. Unable to upgrade connection. No container not found nginx. So it will take some time for container to restart. Let me do K8s pods. It is running, right? So it should restart now. Yes. Let's do it for the final time now. User, share, nginx, html. And now finally it works. There is nothing called a home.html, which basically shows what I'm trying to show here is that if I do not have a volume, then if the container restarts, the data will be gone because the data was tied to the container. So the container restarted and data is gone. But for this case, we killed the container. Actually, we did not kill the container. We killed the root process of the container, because of which the container had to be restarted. And when we went inside again, we found our home.html as well as index.html. If you want to check, you can see we have home.html and the data we stored, and also the index.html. So this is basically how the emptyDir works. And finally, we can move on to the other types of volumes. So the other one let's talk about persistent volume claims. For that, we will go to the persistent volume section. And like I told you, it is persistent and it is not tied to the container's lifecycle, to the pod's lifecycle. So even if the pod dies, the persistent volume still remains. So let us see some examples. These are the different policies. We'll talk about them. Let us see some example. I think this one will be good because we are using hostPath here. Now, persistent volume is not usually used the way we are going to use it. We are going to uh, like use a host path which will be mounted as a volume. Uh, but in like production level clusters, you will use a separate storage or storage service by AWS or Azure or GCP. But just for this tutorial, we are going to use host path. Okay, so fine. What I have, I'll use that only. Let's create a persistent volume.yaml. Let me paste everything here and then we can make changes. I'll not call it PV3. Let's call it 1GI. And volume mode can be removed. Access mode is important. Read write. And then persistent volume claim. Okay, that is also important. Let us leave that. Let me exit first. We are in the wrong directory. Let's go back here and we can have some folder here, right? So that would be fine. Okay. Why did everything got deleted? Close it. I created a pv.yaml, right? Okay, I created the pv.yaml in that folder. Oh no. Oh no. I'll have to go back there now. And we have our pv.yaml here. Now we can do pv.yaml and edit and come back, Shift G. Let's call it vol/data. And I think it should be good to go. If there is some issues, we will figure it later on. Let's apply this. It gives us some warning, but the volume is created. Let's do k get volume. There's nothing called volume. Is it volumes? What is it called then? PV? It is persistent volume. So we have to write the complete name. No problem. Let me do it like this. Yes, that's better. And let me first clear everything because I cannot see it because of my recorder banner, screen recorder banner. And now let's do k get pv. So we have our persistent volume named as pv. Status is available if you see. And then we have this reclaim policy as recycled. The access mode is read write once. So we have to remember this and we have to use that in our PVC as well. So now we will be creating PVC. If you remember this diagram, what happens here is we create a PV, we create a PVC, and we can use our pod. We can use this PVC in our pod so that pod can access the PV. Let's go back. Let's create a PVC. I'll call it pc.yaml. And then paste the content here. Change the name to something better, which is PVC. That's all I can think of. Remove the namespace. Storage class. We don't need that. Access mode should be read write once. Yes. Resources, requests, and storage. So we do not need 1 GB of storage because it only has 1 GB of storage. So we have to reduce it. Let's call it 500 MI. And I think that will be good to go. Yes. So it has been created. K get PVC. It is pending. So it is still in pending state. Let us create a pod, and then we will use PVC in that pod to access the PV. Maybe then it will not make sense. So let us create a pod. Let me use the dry run client command in this one. So kubectl run nginx image would be nginx dry run is equals to client. Anything else? YAML format output. Let's keep it at pod.yaml. Vim into the pod.yaml. Here we are going to use the PVC in the container. How do we do that? We can find it up here somewhere. So in the image, we should have this thing down the image, right? Yes. I'll remove this resources. DNS policy also remove. Restart policy remove. Remove all this. Here we have it. So we have this nginx pod. Also, let me do one thing. We created a few pods, right? Okay, get pod. Okay, let me first exit. We are in the control plane, so we can do get pods. And now let me delete these pods. Delete pod. So they have been deleted. We will do the same thing in the same directory here, which was user slash share slash user slash share slash nginx slash html. So now the volume will be mounted in this particular directory. Name of the mount volume. It will be pv. And then in the same level as containers, I think so, the same level as containers. Yes, we have a volume. We will name that volume. We go here back, paste it here. So we'll name that volume, which is PV, persistent volume claim we have to provide, which was PVC, as far as I remember. So I think this should work fine. We have everything here. Yes, I think it should. We created the pod. Let's do get pods. It says pending. Let's try logs. Let me describe it. Started container, right? Get pod. It is running, so it was just taking some time. Fine. Now if we do get pvc, it should say bound. Yes, it is saying bound, so it is perfectly fine. Great. So the PVC, which earlier was saying pending, I remember, or whatever, now it says bound because now the pod is using this PVC to use the persistent volume. And the read write once, access mode, everything looks fine. Volume says unset. Why is it so? If I say get PV, I'll have to small make the font smaller for now. Let me clear everything and do it again. Okay, so volume was not unset. The volume attributes class was unset. So get pvc. It does say bound. I think it is correct now. Now what we can do is we can do k exec it. Now let me increase the font. Let's go to nginx bash, and we will go inside the user slash share slash html. No, nginx html. We have nothing here. Sometimes you have html, sometimes you do not have html. I don't get what's the thing here, but we will create an echo, and this time we will create something else. We'll not create this in index.html. We will call it, that's okay, call it home.html like earlier. Right? Great. We do have a home.html. Exit. Now what I'm going to do is, I think this video has gone already very long, but let's continue. So yes, what I was saying was that we have to now delete this container, delete this pod, because the persistent volume, as it is persistent, so it is independent of the pod's life cycle. Even if the pod dies and is restarted, it will still be able to access that particular data in that particular PVC, in that particular persistent volume. So let's delete pod called nginx, deleted. Let's apply it again. Get pod. It'll take some time. It is running. Let's do exec again. And now if we go to the same folder, which was users, user slash share slash what is it called, nginx slash html, and if we do lx, we do have a home.html, and if I cat inside it, I'll see the same data 1 2 3 4. So now you can understand why is it important, because in case a pod failure occurs, pod is restarted by the deployment itself, even at that case we will still have our data secured. Now we can exit it, and I think I have covered two crucial aspects, or the two crucial types, the most important types: emptyDir, persistent volume claim, and we have also covered host path, because it works quite the same. I mean, host path, as the name suggests, is doing what? It is using the directory of that node, a particular directory of that node, as the host path, and that is the same thing we did with PV as well, because usually PV would be using some storage from from some cloud service, or something like NFS. But in our case, we used host path, and we used this persistent volume. We created this persistent volume directory in the in the node itself. Okay, so it's been more than 1 hour now. It's been more than 1 hour, and the what do you call it? The cluster has been deleted, because the killer coda only gives access to a cluster for 1 hour. Maybe we can extend it to a two-part series. In the second part, we will talk about host path, and we will also do a bit of tutorial on these config volumes, not config volumes, config maps and secrets. And then we will also talk about dynamic provisioning and storage classes. And thank you for watching this one. I hope you watch the next one as well. But in either case, thank you for watching this one, and I'll see you in the next one.